Hello. So now we will study the viscosity. This viscosity as a concept, it is similar to the friction we used to discuss in case of forces, dynamics. In this case, like if we are having fluid and if that fluid is moving, there are multiple layers of the fluid, and if the multiple layers of the fluid is moving, between the layers there will be friction. And as we studied in case of dynamics, friction has two types. Basically, one is static friction and one is kinetic friction. Friction is similar in both the cases, it's same, but the thing is behavior of the friction is different. When there is no relative motion between the objects, then the static friction acts, and when there starts the relative motion, at that time kinetic friction starts acting. So similar concept if we export here in that case and we study it here. So you see, if there are layers, multiple layers are there. These are the layers I've shown. These are the particles in the layers, different layers. And this is the topmost point. And we are applying this concept for a canal type of structure, meaning there is a flat surface down and there is an open surface up. And in this case, there will be parallel liquid surfaces. There are parallel liquid surfaces. So you see, this is a layer which will be in contact with the earth. And this is a layer which is farthest away from the earth. So let's start from this layer. So this layer and this point which is in contact with the earth, and earth will not be moving. So this point will experience a friction force which will be coming from the bottom. So this point, if this whole liquid is moving in the forward direction, then this point will experience some friction force in the backward direction, and that friction force is coming due to the rest nature. Because this is at rest, this is the friction force. This is the friction force, and I'm calling it F. So these particles, let's number these particles. This is 1, this is 2, this is 3, and this is 4 as it is. It will go till infinity. So this one particle which is just contact with the earth will experience a friction force in the backward direction. And earth I'm calling 0. So this is a friction acting onto 1 because of 0, which is the particle onto the earth. You see, before experiencing this friction, all these particles were moving with same speed. Now, the moment this particle will start experiencing some friction in the backward direction due to the earth, this particle will slow down. And if this particle will slow down, if we start looking this particle with respect to the particle 2, if I start looking one particle with respect to particle 2, then with respect to 2, this particle will slow down, or I should say this particle will start moving backward. One more time. Before application of this friction, 1, 2, 3, 4, all the particles, they were moving with same velocity. If I look at any particle with respect to any other particle, the relative velocity was 0. Meaning both 1 and 2 were moving with same speed or same velocity. So if I look at 1 with respect to 2, the velocity is 0. Or if I look at 2 with respect to 1, velocity is still 0. So when the velocity is 0 or relative motion is 0, there is only two outcomes. Either the friction is not acting, or if it is acting, it has to be static in nature because relative motion is not happening. Now, due to the earth, because since at earth the friction is available, due to the earth, and earth will apply the friction force or the force onto 1 only because earth is in direct contact with 1, not with 2. So earth starts applying the friction force in the backward direction because with respect to earth, particle 1 was moving forward. So when this earth starts applying a force onto 1 in backward direction, this particle 1 will slow down. And the moment particle 1, it is still moving forward, but it will slow down. So if the moment this particle 1 slows down, particle 2 will, with respect to particle 2, particle 1 will look like it is moving backward. The moment with respect to 2, particle 1 will look like it is moving backward, particle 2 will apply a friction force opposite to that relative motion. As we learn in dynamics, friction always acts opposite to the relative motion. So with respect to earth, 1 was moving forward, so relative motion was forward, so friction was applied backward. This is the friction applied by the earth. With respect to 2, particle was moving backward, so friction was applied forward. This is F12. This is applied on 1 because of 2. Applied on 1 because of 0. Okay. Now, this force is applied by 2 onto 1. F12 is applied by 2 onto 1. So, action reaction, due to action reaction, particle 1 will apply an equal and opposite force onto 2. So F12 equal magnitude but in opposite direction. So particle 1 will apply friction force F21 in backward direction. You see, this F12 is equals to F21 due to action reaction. This is due to action reaction. Third law. Due to third law. So particle 2 apply the friction onto 1 in forward direction because of the relative motion, and particle 1 will apply a friction onto backward direction because of action reaction. Now let's move on to 3. If particle 2 is experiencing this friction F21 because of the lower particle, this particle 2 will start slowing down. Before that, every particle was moving with same speed. So this particle 2 will slow down. If this particle 2 will slow down with respect to 3, this particle 2 will look like it is moving backward. With respect to 3, this particle 2 will look like it is moving backward. So what this particle 3 will do? It will apply the friction force onto 2 in forward direction. So this F23 is coming because of the relative motion. It is coming to oppose the relative motion. So F12, F23, etc. There will be more also. They are coming because of 2 oppose the relative motion. No other reason. They are just coming to oppose the relative motion. So F23 is applied by 3 onto 2. Action reaction one more time. If we apply the action reaction, this 2 will apply friction force onto 3, F32, which will be equal in magnitude and opposite in direction. Similarly, because of this friction force, 3 will slow down, and when the 3 will slow down, 4 will apply a friction onto 3 in backward direction. Because it will slow down with respect to 4, it will look like it is going backward. So F34, and this will go on throughout. So one more time, these were the layer, and before the application of friction force, if this surface was not having any friction, each and every particle was moving with same velocity. When each and every particle was moving with same velocity, relative motion of any particle with respect to any other particle, if you look for, relative motion was 0. And when the relative motion is 0, there are only two possibilities. Either the friction is absent or friction is acting, but that is static in nature. Okay, so that was a condition. Now, because of this surface, friction came. This surface, it has a friction, and because of that, the particle which was in contact with surface, it starts experiencing a friction force. This is the friction force it starts experiencing. This is the only friction force. So because of this friction force, particle 1 starts slowing down. It was still moving in forward direction, but this time with a slower velocity. When it is moving with slower velocity, the particle 2, which was moving with the same velocity, with respect to particle 2, particle 1 will look like it is moving backward. So relative motion of 1 with respect to 2 will become in backward direction. To oppose that, F12 will come. F12 is coming to oppose the relative motion, like this. So F12 will come. Now to apply a force onto 1, so action reaction will tell us that F21 has to be applied, equal and opposite. So F12 and F21, they were same. So F12 was applied by 2 on 1 and F21 was applied by 1 onto 2. They were the action reaction pairs due to the third law. And the same process will follow for all the other particles. Clear? Okay. So now let's study particle 1 or any particle. If I study any particle, and for a time being if I study the one particle, this particle 1 is experiencing two forces. One is F10 and second is F12. Particle 2 is also experiencing two forces, F21 and F23. Particle 3 is also experiencing F32 and F34. Each and every particle will experiencing the two force except the top one, because the moment you reach the topmost particle, there is nothing above. So this type of force will not come. So the topmost particle will experiencing only one force. Other than that, each and every particle is experiencing two forces. And both forces are in different direction, opposite direction. So now the motion of any particle, or either it is 1 or 2 or 3, motion of any particle will depend upon the net resultant of these two forces. Like if if I make FBD of nth particle, let's make it for one particle. If I make the FBD of particle 1, the FBD will look like that. It is experiencing a forward force F12 and it is experiencing the backward force F10. Now, based upon the relative magnitude of these two forces, this particle might have the acceleration in forward direction or it might have the acceleration in backward direction. The thing is, in the beginning, the force starts from the bottom. This force will dominate this one. So, particle 1 will slow down. It will slow down. Similarly, particle 2 will also slow down with respect to its original value. And each and every particle till the topmost point will slow down to its original value. They will slow down. So they will keep slowing down till they achieve the steady state. Meaning that this will be a dynamic situation, and as you know, in classical physics, we don't study the dynamic situation. So all these particles, their velocity will keep changing. Their velocity will keep changing because of the acceleration coming because of these two types of forces. So at one point of time, when their velocity will become constant, I'm not saying equal, I'm saying constant. When their velocity will become constant, at that point of time, when velocity will become constant, or we can say acceleration of the particle will become 0. Each and every particle will become 0. At that instant, F10 will be equals to F12. At that instant, the friction forces will become same. You see, when the F10 will become F12, this F12 is already equals to F21. So this is for the one particle, first particle. For the second particle, F21 will be equals to F23. And you see, F23 is equals to F32. So you see, at steady state, these two forces, they will become same. But at the same time, these two forces are always same because they are action-reaction pair. These two forces are always same, they are action-reaction pair. So all these forces are already same, which are the action-reaction pair, but when these particles will achieve the steady state, these two forces will also become same. So at the steady state, we will be saying, at steady state, we will be saying that F10 will be equals to F12 will be equals to F21 will be equals to F23 and so on. These two will become same because of the steady state. Because of a steady state, and these two, they were always same because of third law. So in the end, you will see each and every particle will attain the constant velocity. That velocity will not be same because each and every particle was moving with different velocity. Okay, that when they will achieve the constant velocity, each and every particle will achieve the constant velocity. When I say constant, I mean constant with respect to time, not with respect to location. With respect to location, their velocity will keep changing. So if this axis I'm taking as Z, then at any point, for any particle, the velocity will be a function of Z. But this velocity will not be a function of time. Before achieving the steady state, the velocity of any particle will be a function of two things, Z and time. For different particle, it will be different. At different time, it will be different. For before achieving the steady state. But when they will achieve the steady state, the velocity will be a function of Z and Z only. That's what will happen, meaning each and every particle will be having different velocity, but at different time their velocity will be same. Each and every particle will be having the velocity as a function of Z. The velocity as a function of Z, it will keep changing, but not with respect to time, with respect to height. It will keep changing, and Z I am measuring from Z is equals to 0, that is a surface. Z is equals to 0, I am taking at the surface. So this velocity will keep changing with respect to location. One more time. So you see, these layers were there. They are multiple layers, and when the friction was not there at the bottom, each and every layer was moving with same velocity. Because there was no friction, there was nothing. They are supposed to move with the same velocity. The moment friction comes from the bottom, this friction from the bottom will prevent the motion of particle 1. Just hinder the motion of particle 1. So the moment that will happen, the relative motion between the layer will start. And when the relative motion between the layer will start, they'll start applying the friction force. So you see what it says, the friction force was already there. It was already there. It's not like a friction force can be generated from the zero. So friction force was already there. So before this situation, before this surface, if there was no relative motion, it was not because that friction was not there. It was because friction was there, but it was static in nature. So whenever you see each and every particle or each and every layer moving with same velocity, it is because of the static friction acting between those layers. So the moment this particle 1 comes to rest, it will come to rest in the end. The moment this particle 1 starts, its velocity starts decreasing, the relative motion will start happening, and then the friction will come. So these two, friction F12 will come because of 2 and F21 will come because of one action-reaction pair. Similarly, the relative motion will cause the one friction and the action reaction will cause the other friction. Relative motion will cause this friction, action reaction will cause this friction. So this will happen till the topmost point. So at steady state, because till the velocity is changing, we have very little to solve. So when the velocity of each and every particle with respect to time will become constant, that's when we call steady state is achieved. So when the steady state will achieve, these forces will become same. These two forces, and these two forces were already same, always same. So these two forces will become same at steady state, they were always same. So what we can say each and every particle is experiencing two forces and each and every force is same. So whatever force is applied here, that will be the same force which will be applied at the topmost point, but only after achieving the steady state. So with the calculation of this force, I can calculate this force. So at steady state, the friction, this force was coming because of this surface. So at steady state, this force and this force become same. So we can say whatever force is coming from the bottom, at steady state, that force is reached at the topmost point. So whatever will be moving at the topmost point, it starts experiencing the force, friction force, which is coming from the bottom. And at steady state, velocity for each and every particle will become a function of z and z only, where z is the dimension we are taking from the bottom. Z is 0 at the surface. See, now the thing is, when we talk about velocity as a function of z, this function might be a constant function, meaning the fz might be a constant. And the thing is, this might be a variable also, meaning if you make the function, if you make the curve for this, it might be a parabolic function, it might be a straight line function, it might be a constant function. So we will be solving this thing for different functions, meaning when the fz will be a linear function, for that also we will be solving, and when fz will be a parabolic function, for that also we will be solving. Okay.